In this video, we begin our discussion on Chapter 7, where, looking ahead, our major objectives for the course are to develop consumer choice, the theory of the firm, as well as partial equilibrium analysis, where we have already gone through consumer choice to explain how consumers make decisions, as well as to explain product demand through preferences in purchasing capabilities. Now our major task at hand will be the theory of the firm, where over the next 2 weeks we will develop the theory of the firm to explain how firms make decisions, as well as to give a richer explanation to product supply than what we encountered in Chapter 3. Where this first half of the theory of the firm, we will go over production functions, total cost, and average cost, and in terms of today's discussion on production functions, we will consider some preliminaries to then have our discussion on production functions. So to begin with our preliminaries, to develop a framework for how firms make decisions, let us recall what we know about firms. Our firm agents will have wants in the form of profits, and they'll have resources in the form of the factors of production, which will comprise land, labor, capital, and entrepreneurship. They will make choices to transform their factors of production into goods and services to make themselves the best off possible in terms of profits. Where the immediate questions we need to answer for our framework then are: how does the firm produce goods and services? What costs does the firm incur with production? And how much does the firm generate with the sale of its goods and services? Where we will begin by addressing question 1, where a firm will produce goods and services using its factors of production, where this process will define the firm's production function. That is, a relationship that shows the maximum quantity of a good or service obtainable from different factor inputs. That is, the relationship between land, labor, and capital to use to make goods and services with, where a firm needs land for a factory, store, or restaurant, and a firm needs labor in its factory, store, or restaurant, and 0 of any of these factors means that the firm cannot produce or sell their goods or services, where the entrepreneur plays the part in putting all these 3 factors together. And in terms of our production function, key properties that we'll notice will be that more inputs than more output, and diminishing marginal returns. We're observed that these are similar to the properties that we observed with utility. More is better, and diminishing marginal utility. And in terms of diminishing marginal returns, this just means that more input will lead to more output, but not as much output as the last unit of input, similar to what we saw with diminishing marginal utility as well. So then this is going to relate to the concept of the marginal physical product in terms of production functions, which is going to be the change in total output due to a 1 unit change in an input. So the rate of change or the slope of the production function. So then in our discussion of production functions, we will assume that land is fixed in both the short run as well as long run, capital is fixed in the short run and variable in the long run, and labor is going to be variable in both the short and long run. Where in terms of defining the short and long run, the short run is going to be the period in which some factors of production are fixed, whereas the long run will be the period in which all factors of production are variable. And since we are assuming land to be fixed in both the short and long run, our production function discussion will only be concerned with labor and capital. So then, to give some context to production functions, let us motivate this discussion through example, where suppose that we have a firm that uses a fixed amount of space as well as equipment in order to clean cars, so the service that they are providing is cleaning cars. We would like to examine what this firm can do in terms of quantity of cars cleaned on a given day using a variable amount of labor. So then what we have then is a short run production decision in that there's a fixed amount of space as well as equipment, so our capital is being fixed, and they are considering their staffing, so labor is variable. So since that we have capital being fixed and labor being variable, there's some fixed inputs, some variable inputs, and this is going to be short run by definition. So let us proceed on to our example then in terms of cars cleaned given labor used. On the right we'll have our graphical representations. On the upper right we'll have the production function, and on the bottom right we'll have the marginal physical product. In both cases we'll have quantity of cars cleaned on the vertical axis, which will represent our service, and on the horizontal axis for both graphs we'll have the quantity of labor that's being used. So then to begin, if the firm is using no labor, then the firm can clean no cars. We can represent this with point A, where the firm has a fixed amount of space and a fixed amount of cleaning equipment, but since they are not using labor to clean cars with their cleaning equipment in the space that they have, no cars can be cleaned as a result. So we need a positive quantity of all of our factors of production as mentioned, and we can represent this with point A, 0 labor, 0 cars. Then moving on, if the firm decides that it wants to bring an initial person on board to help them with the car cleaning business, then this will allow for some positive quantity of cars to be cleaned, which we can represent with point B. A positive amount of labor is being used, so a positive amount of cars is being cleaned, as we can see with point B. So then what this means in terms of the marginal physical product, the rate of change of production, since 1 unit of labor has been brought on board, that means some quantity of cars is being cleaned. So then this generates a positive point on our marginal physical product, in which we have point B, positive quantity of labor, and a positive quantity of cars that's being cleaned as a result. Now, if the firm decides to bring a second person on board, using more labor, the firm can clean more cars, but not as much as bringing that first person on board, either due to a lack of space or not having enough cleaning equipment. So then how we represent this in terms of our production function is that we go to point C, where we see there's more labor being used and further quantity of cars being cleaned as a result. And what this means in terms of the marginal physical product, since a positive amount of cars are being cleaned due to this unit of labor being used, we have a positive quantity of cars being cleaned on the marginal physical product, but since they are not as productive as our first unit of labor, it's going to be strictly below point B. So then this generates a downward sloping curve that we initially see here with our marginal physical product. And then if the firm decides to bring a third person on board, by using even more labor, the firm can clean additional amounts of cars, but not as much, since once again they are limited by either space or their cleaning equipment, since both are fixed. And what this means in terms of production is more labor being used, then more cars can be cleaned, as evident with point D. And in terms of our marginal physical product then, once again, since a positive amount of cars is being cleaned with this third person being brought on board, this means a positive amount of cars being cleaned, but since they're not as useful as our second and first person, they're going to be strictly below points C and D. So then what we have then is a positive but downward sloping curve with our marginal physical product. So then where observe in terms of our production function, marginal physical product, and as well as our table representation of both, we saw then as more labor was being used, more cars can be cleaned. We can see this with our production function going from A to D, more labor, more cars cleaned, more inputs, then that means more output. We can also see this with our table representation going from points A to D, where labor is varying from 0 units of labor to 3 units of labor, and cars being cleaned goes from 0 all the way to 17.32 cars being cleaned. So then, due to this property of more inputs than more output, this then leads us to seeing also that the most cars being cleaned is going to occur when the most labor is being used, which is going to occur at point D in terms of our graphical representation of the production function. And we can also see this in our table representation. At point D, with 3 units of labor, the amount of cars being cleaned is 17.32, which is the highest of all other varying quantities of labor. And then now moving on to our rate of change, or our marginal physical product, we saw that each additional unit of labor brought about more cars being able to be cleaned, but not as much as the last unit. And we can see this with our positive but downward sloping marginal physical product. We can also see this in terms of our table representation, where going from A to B, 0 units of labor to 1 unit of labor, we see this allowed for 10 cars to be cleaned. So the marginal physical product was 10. Going from B to C, bringing on that second person on board, allowed for 4.14 cars to be cleaned due to the difference of 14.14 and 10, which is also positive. Then going from C to D, bringing that third person on board, allowed us to clean 17.32 cars. And in terms of the difference of going from the second to the third person, this is going to be 3.18 cars, where once again this is a positive quantity, where then overall what we see then is that the marginal physical product is positive but declining, just as we see in our graphical representation. And the rationale for this is due to our law of diminishing marginal returns. That is, as the marginal physical product declines, as more of an input is being used, given that our other inputs are fixed, where in this case it's going to be the capital in terms of our fixed equipment and the space that it's being used. This then leads to the marginal physical product then to be highest at its initial point, or if you look at our graphical representation, this means point B. And if we look at our table representation, this also means point B, where 1 unit of labor has been brought on board, where we saw this led to 10 cars being cleaned, so our marginal physical product value was 10. Where we'll pick up in our next video is we'll discuss the costs associated with production for a firm.